Each new observation we communicate adds to the pool of collective knowledge, like each text message building out the larger conversation. Often, a hypothesis gets tested over and over and over again from different angles. And then it gets linked up with other hypotheses that are getting tested over, and evidence for all of them keeps accumulating like a tiny snowball rolled into a massive snow conclusion. A snowclusion. I'm still working on that analogy, but anyway, that's how you get a scientific theory. It's not a theory like your neighbor's speculation that his cat was King Tut in a former life, but when we use the word theory in a sciencey way, that means that the bar for evidence is high. Scientific theories are backed by strong consensus from the scientific community based on a broad range of evidence. And theories are the basis for studying a subject. Take the Big Bang Theory, the idea that the universe began with a massive expansion event. There's still so much to study about the theory of the Big Bang, like the study of leftover energy from the expansion of the universe. And more research is being done all the time, spurring more testable hypotheses that add depth to the theory. New theories are always being revised, whenever enough new evidence piles up that doesn't support them in their current state. And then there are laws. Very precise, universal statements describing something that always happens in the physical world. For example, the first law of thermodynamics says energy cannot be created or destroyed. And it applies to everything, including life. Energy takes different forms as it passes through plants and animals and soil, but the total amount of energy stays the same. For any scientific idea to become a theory or a law, it needs to be backed by a groundswell of evidence. Scientists decide how much evidence is enough and what it all means through a process called peer review. Scientists will submit their research by writing up what they hypothesized, how they tested it, and what happened. But before their work makes it to the wider world, it gets checked by their peers, other scientists who are also experts in their field. Peer review isn't perfect, but it's a really important way of catching mistakes or even outright fraud before papers make it out into the wider world. That means the world's experts on platypuses are discussing and reading other platypus experts' work before it even gets published. And you can bet that group chat is fire.